Hello everyone, can you guys hear me? You can just type an yes in the chat if so. Yes, good. Is it clear or is it a bit of fumble or something? Because I'm currently not using my headphones though.
It's clear. It's very clear.
Thank you. Let's hold on for couple of more minutes for others to join in. I'll probably start in 2 to 3 minutes, guys. A very good evening, guys. We will be starting now. If anyone is joining, they'll just join in the middle, okay? And yeah, let's continue. So, my name is Anupama, guys. I will be the host and the instructor for today's event. And I welcome you all, and I hope you have a really happy and a learning session. So, this session is about the data structures and algorithm, and I'm sharing my screen. Please let me know if anyone is having any troubles. I will try to fix that. And yes, so I have few theoretical session and a bit of questions that I'm going to practice. Before that, I'm just going to quickly introduce myself and do a very small interactive session with my today's folks who are present here. So I have somewhere around like plus years of teaching experience, and then I have been into industry for more than 5 years of industry experience. So I come from one of the fan companies. So yeah, that's about me in a nutshell. So I'll be really happy if all of you can go ahead and just type your name and maybe details and probably how much experience you are, like 2 years experience, or you're in industry, seasoned experience folk who's like 10 plus 15 plus or something like that. Just so that it'll be easy for me to connect with you and go accordingly, so that I'll pick the questions accordingly for today's session. Okay, any questions or mm, oh great. Hi Sanjay, that's amazing, 15 plus years of experience, great. And if you're comfortable, maybe you can write where are you from, and you can also leave a phone number for us so that we can, catch up with you later. How about others? Quickly, I'll just give you probably a minute of time. Everyone can introduce themselves in the chat. Oh, hi Chinmay. Admit. And also, I want you to do like one more thing. Like, I also want you guys to rate yourself in terms of DS Algo, like how good you are in DS Algo. Are you like really an expert, like on the range of like 1 to 5? Rate yourself. Like, are you probably a five being like the toppest? You're a expert. Like you eat interview questions for your breakfast, something like that. Okay, I have like rating 3, grade 2. Okay, how about others? I'm in college. Great. I have all the folks here from 15 years experience to college kids. Amazing. I think this goes for the college also, guys. Freshers, seniors, just out of college. Rate yourself on in DSL, how good you are. Great. Others, anyone interested in sharing with me? Oh, congratulations, Neha. Great. Hi, Sanjay. Hi, Wasim. Okay, so we have 1 more minute. Just go ahead. I think average is, I can say, 2 to 3. Most of you are saying 2 to 3 right now. Yes, I'll go 3. Cool. Okay, guys, just give me a moment. I am getting one call. I'll just quickly come back in a minute. Okay, I'm back. I'm so sorry. Okay, so let's get started. So today I am planning to talk about a really really amazing data structure. It's a bit of like mid tier to medium, I can call it. So have you guys heard about trees? Tree data structure? Oh my gosh, there's a lot of people waiting for me. Yes, correct. Okay, perfect. So, a quick repeat. Okay, hi guys who have recently just joined in. I am just starting by. You guys can go ahead and drop your name and your details like your experience, probably where you're working for, and all of the things like that. And then, uh, 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 yeah, and rate yourself. Like how good you are in data structures, starting five being the toppest and one being the lowest. Okay. Cool then. So for today, I am going to talk about tree data structure. I'm going to start with the basic questions. Like I'm going to teach, like this is how your actual classes would also be. I'm going to talk about what a tree data structure is, and then I'll go ahead and solve some questions around that. Can everyone see my screen? So feel free to chime in anytime, guys. I have an eye on the chat. So if you have any queries or anything like that, just message that. I'll get back to it. And I think I'm sharing my tree slideshow. Is that visible, folks? I hope so, though. Okay, cool. Let's get started. So, yeah. So before going any further, I just want to ask one more question. Okay, that's fine. I'll just probably ask it later. No worries. So what is a tree? So what is the typical definition of a tree? So in computer science, a tree is a widely used abstract data type that simulates a hierarchical tree structure with a root value in a subtree of a children and with a parent node and represented as a set of linked nodes. So a tree, what is a tree? Tree is, I can claim as a bit of a complex data structure and also an abstract data structure. So it have a lot of terminologies. We're going to see in the further slides what are the different terminologies which are associated with a tree. So here is a quick glance at a tree, how if we represent it. Obviously, this is not how your code will be saving though, but yes, we're going to create our code to save in this structure. It's definitely not going to be like a hierarchical and vertical though, but yeah. But this is how the representation of the code would look like. So it always starts from the top, which is called root. Then it have levels. As you can see here, we have level 0. Let me zoom in further. Yeah. So let me close this. I don't know. How should I close this? Yeah, perfect. So we have this root on the levels, and then the nodes which doesn't have any further levels, that we call them as the child nodes. So in this case, can anyone guess what are the child nodes? Maybe they can just type in here. What are the child nodes, guys? Can anyone guess it? Okay, that's great, Chinmay. How about others take a quick look at the child nodes which are here? Yeah, that's absolutely correct. So here the child nodes are H, I, J, F, and G. The reason being is none of these have any we can say child nodes or the leaf nodes, guys. The sometimes we can interchange the meanings, but yeah, I'll go in depth what exactly they are. So all of the all of the nodes which doesn't have any further levels, or if they come from a parent, we call them either child nodes or we call them as a leaf nodes. So when do we call them a child or when do we call a leaf node? When we have with respect to a node, when we're talking with respect to a node, then we call them as a parent child node. In this case, we call D as a parent node and H and I as a child node. But if the child node definition is saying that is if it's being at the last level, then obviously you're going to include H, I, J, F, and G. So sometimes some questions they interchange. So probably in your interview also, your interviewer might twist the definition of it. So it's better like you get on board with your interviewer before you actually go ahead and solve your questions. So today I'm going to solve a real time those interview questions, rather I can say FAANG coding interview questions, okay, on trees. So next we'll see some important terms: path, root, child, leaves, subtree, traversing, levels. So we know what levels is, we know what root is, parent is, child is, leaf is. A subtree is a part of a tree. A tree is whole from, okay. One more thing about the trees is, guys, that you see we don't have any directions because we understand it always goes from top to bottom. Like a parent or a root would know what its child nodes are, but a child node would not be knowing who is its parent is. That's how it's defined. So, and also the concept of trees, it comes from, a lot of other concepts such as arrays, linked list. So we need to have a bit of prior knowledge on it. If you take up the entire course, we start from the basics and then we go ahead and probably this trees and other data structure would come in the middle to the end of the course. But right now I'm just going to touch base all of these terminologies and go ahead to solve some questions. So these are the important terminologies. And then we have other terms also, such as neighbor, distance, ancestor, descendants, branch node. All of these words you will be seeing in the different questions of the trees. Okay. And there are also different type of trees, guys. We have general tree, binary search tree, ABL tree, red black tree, NRA tree, and everything. So tree is just a data structure. It can have various variations in it. I think the most popular one is binary tree. Can anyone guess what is a binary tree, guys? Any guesses?
The tree with maximum two child.
Yeah, that's absolutely correct, Ankit. So a tree with two children is called a binary tree. We restrict the number of children in a binary tree. Anyone wants to guess what is an NRA tree?
A tree which has zero or n number of child that called a narrative.
So this is a binary tree where we restrict the number of children to two. But as I think Manish said, an array tree is a quite an opposite of it. A tree which can have any number of children. We do not put any restriction to it. It can have any levels of and any number of children it can have. So that is called an array tree. Okay, we also have seen something called a binary search tree. Binary search tree, BST is the short form of it. Anyone wants to take a guess what is a BST tree is? No? Well, the first and the last part we have seen BT, which is binary tree for sure. So the difference between binary tree to binary search tree is that, guys, there are some conditions to it. So what we say is, if this is our root node and this is our right node and this is our left node. So the condition is, if the new value is greater than the root, then it should go on the right side. So this is basically should be assigning to the right. If the new value is less than the root node, then we're going to assign it to the left side of the subtree or the left node. So I'll quickly take an example here and I'll explain you how exactly we construct a binary search tree. So for example, if you have an array of values such as 10, 5, 15, 2, and then 3 and 4. So let's assume these are the values. So initially, the first value, I'm going to consider that as my root node because I don't have any values. And then that's a really quite odd big circle. But that's fine. So now this is done. Now we have 5. So where should be 5 going, guys? Any suggestions left or right? Left. How about others? Can others also put in their thought process in the chat? It's fine, even if it's wrong, right? We'll see that later. It'll just make me understand that you guys are following with me. Yeah, perfect. I have few more. Anyone wants to guess where would the next value 5 would be going? It's the left. The reason is 5 is less than 10. That is the reason we send 5 to the left side of the tree. So we send 5 here. Now 5 is also done. Next is 15. Anyone wants to guess where would the 15 would be going? Perfect, perfect, perfect. How about others? Others can also take a stab at it. Take a wild guess, even if it's not correct, it's fine. Great. So 15 goes to the 10, the right side of it. Here, because it's greater than 10, obviously, all of you are right. So this is done. I'm just going to scratch it off. Next is 2. Now, the thing is, you are done with the level 0. So this is what we call level 0. This is called the level 1, which is done. So now we have to go ahead and fill in the level 2. So if you see it's the level 2, we will be having, like, since it's a binary tree, we cannot have more than 2. So this and this, these are the new available positions. We need to figure it out. So now when you have a 2, where would we be sending 2, guys? Anyone? 2 left of 5. Absolutely correct. It will be going to the left of 5. First of all, 2 is less than 10. And then at 5, we decide again if there's an empty, we would have placed it there. If not, we again do the further same point. Like, is it going to left or right? Since 2 is again less than 5, we're going to send it here. Okay, 2 is done. 3 is again, 3 is less than 10. So that means it will come all the way from here to here. And again, 3 is less than 5. It will come here. But 3 is actually greater than 2. So we are going to put 3 here on the right side of the 2. Is everyone following with me? Clear or any doubts? Anyone is confused? I can repeat myself. It's fine. Clear? Great. Admit. No dots. Perfect. And again, 4, it's going to be the right side of 3 because that's greater than that. So this is how a typical binary search tree would be constructed. In case of a binary tree, for the same example, if you ask me to create a binary tree, the tree would be simple. We just fill out the details like 10, then we say 5, and then we say 15 here, and then here 2, 3, and 4. So mostly in binary, what we do is we go level by level. We fill out all the empty spaces in a level. So if this is 0th level, that's an empty thing. Then it is like an empty value here, empty value here in the level 2, here, 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 here. From left to right, we try to fill out. Okay. So once one level is filled, you go for the next level. But in case of a binary search tree, that is not how it is. So this is a binary tree. This is a BST. Okay, I have a question here. So Abhishek is asking why 4 is not on the right of 5? Because 4 is less than 5, isn't it? 4 is less than 5, but then we have 2 here, which is already filled value, but 4 is greater than 2, so it goes on the right side. But then we already have 3 here, which is again greater than 4. So 4 is greater than 3, so it goes onto the right side value here. The right side values are always greater than the root. And the left side values are always less than the root. Making sense? Did I answer your question, Abhishek? So this is the formula to construct a binary search tree. But if I put 4 in the right of 5, then the roots are broken. To be honest, it's not. But if I put the 4 in the right of 5, then the roots are not broken. How the roots are not broken? If I put 4 here, did you see the rule? If the new value is greater than the root, then the right. Is 4 is greater than 5? Is this a true and false? False. Then we don't. That is the reason it's on the left side, left subtree. Great. Okay, so we'll move ahead. So this is the basics of the tree and everything. Typically, the code representation of the tree would be changing from the kind of a data structure that you're going to use and how you're going to implement. Some people will be going ahead and creating a struct in case of CPP and C, and some people will create a new class object and give them the field values and blah, blah, blah. So, but for today's class, I am not going to concentrate on all of that, but rather I would just move ahead and, you know, simply take a look at other interview questions with respect to the trees. Clear? Anyone have any doubts in theory of trees maybe? If yes, I'll just wait and I'll answer them. If not, I'll just move on to the questions. Can I move on, guys? Yes, no, maybe. So for this session, I'm going to use lead code. I personally love lead code. Let me just delete my code. Okay. Can everyone see my screen? Is it visible, the question? Or should I increase the font or something like that? Cool. So this is the most easiest and the basic question that I think it's going to be in the interview. So as you can see, there are 5,000 likes to it. It's a quite a bit of popular question, I think so. It was asked to me also in few of my interviews, so I think yes, I also love it. So let's start. So I'm going to give you 1 minute of time to go through the question and maybe come up with your own a bit of ideology maybe. But before that, I'll just explain the question, then you can also read the question. So given the root of a binary tree, return its maximum depth. So this is how the typical questions are. He's saying some maximum depth. So what is this depth? So in the question itself, they will be asking. So in a typical interview, guys, your interviewers sometimes they don't put down those information. So you have to ask the reason why they don't put down the definition of depth or what their meaning is, because they're expecting you to ask it. So ask and get clarified upfront. So a binary tree's maximum depth is the number of nodes along the longest path of the root node down to the farthest left leaf node. So basically, all these words is meaning is making sense. It's like what is the level of it? What is the maximum level you can have it? So in this case, they are starting from I think 1, 1, 2, and 3. So the depth is 3. So what we were calling here level 0 and everything. So they are calling that as level 1, level 1, 2, and 3. So it's absolutely fine. It's up to the terminology and the naming convention. So let me just explain you what is the depth. Depth of a binary tree. So let's see that if I have 1, 2, 3, 4, and 5. So I'm going to call this as my level 1. This is level 2, and this is level 3. So we know that the last leaf node are the children nodes that are here, here, and here. Agreed? So this is our leaf node, this is our leaf node, this is our leaf node. So being these as my 3 leaf nodes, if you look at what is the height or the depth of it, this is on the first level, these guys on the second level, these guys on the third level. So the maximum depth for this tree is answer is 3. So let me take a different question, or maybe just change it by a little bit. Let's say that if your tree is something like this, what is the maximum depth? Can anyone guess it? Three. Okay, I have one answer as 3. How about others? Four. I have 4. Take a wild guess, guys. So the answer to this question is 4. The reason is I wrote in the red color the levels. So 1 being the root node starts from the first level, 2 and 3 being the second generation nodes, which are being on the second depth. Third is 4, 6, and 7. Then fourth is 5 and 8, which is the last. So in this case, the answer is 4. So let's assume if your tree is something like this, if your tree was maybe having 10 or 11 or 12, okay, and 13, something like this. In this case, the answer would have been, I have a 5th depth, 6th here, and 7th here. Oh, sorry. 7th here. Yeah. A 7th depth here. So the answer would be 7. So earlier the answer was 4. Now the answer is 7. Is everyone clear how the answer is 7 or 4? Yes, no, maybe. Should I repeat the solution, guys? Yes for repeat, or yes, you understood, Wasim? Understood. Great. Does the root is not level 0? Oh, that's a really good question. So one of our friends here asked me, does the root is not a level 0? That is entirely up to the definition or how the question is formed. Tamis, I guess. I'm so sorry if I'm pronouncing your name incorrectly. So sometimes we say that as a level 0, as if you would have been in from the session from the beginning, the PPT which I shared earlier, it was saying level 0. Now it is, I'm calling it 1. It is defined based on the question. In this question, they are starting from 1. That is the reason they got the answer as 3. 1, 2, and 3. If it was starting from 0, it would have been 2. 0, 1, and 2. Got it? Great. Okay, so I'll just leave you guys and I'll give you a minute of time to think through how you will be solving this question. And now I want you to come up with your algorithm. So if you're comfortable, after a minute, I will, unmute you guys. You can just explain me your approach. If not, you can just put on your approach in the chat and I'll go through that. Okay. And I'll highly recommend each one of you to come up with your own approach. It doesn't matter what kind of it. I don't want the optimized version. I want the brute force approach. Don't think about optimization at all. Okay, anyone? I don't see any chat approaches. That was quite a bit sad. Anyone would like to share, maybe unmute and discuss with me? No one? Okay, cool. Okay, then probably I'll only talk about the approach. So the brute force approach for this is, guys, what we are going to do is we're going to start from the root node and then check the different levels of it. Okay, so first of all, I'm going to start here. Okay, this is where my starting point is going to be. Then I'm going to check if this is the end of my tree. If it is, then I'm going to just say that, dude, I reached the end. Then I'm going to just say I have only one. So what I am going to do is, in the earlier, as you have seen above, we were naming the numbers from the below, sorry, from the top. So what I'm going to do is I'm going to do a reverse of this now. I'm going to say this is my level 1, this is my level 2, or this is my level 3. Can we do that? I'm going to do a reverse approach here. Everyone following with me? So why am I doing this? Simply, I'm just asking each node to tell me what is the maximum depth it have. So at each level, so at each node, what is the question? The question is, what is the maximum depth it have? So this is a question I will be asking each node. So I'll start with 3 and I will ask it, what is the maximum depth I have it here? But the thing is, I have my children. Here I have a left child and a right child. So I cannot define constantly, but I can ask my left and right and then I can tell it. Does that make sense? Everyone? So if I ask this question, how to answer is, find the depth for left child, then find the depth for right child. Then I'm going to say a max of left comma right plus 1. If I call this as my left and right, the depth of it, then I'm just going to say plus 1. So if I just take this example, just a moment, I'll just take this thing from here to the a better, cleaner place. I think this is better. Z. Okay, this is fine. Yeah, cool. So what I'm going to do, guys, is at 3, at level, okay, I need to change just a moment. So at 3 node, I'm going to ask what is the left and what is the right. So first I'll talk about the left and then I'll come back and I'll figure out my right. So at left, who's my left node here, guys? Anyone wants to take a guess? Who's the left child of 3? It is 9. So again, I'll ask the same thing. What is the left and what is the right? So we don't care about the right at the moment. We care only about the left. So the left of 9, left of 9 is, anyone? Left of 9 is? None or null. There's no one. There's nothing. It's dead. It's a leaf node. So I'm going to say I don't have anything. So I'll just say, there's no one. written 0. So the maximum depth at the left of 9 is 0, guys. Making sense? Why it is a 0? Everyone, why it's a 0, guys? It's very important. This is a crucial step. Everyone clear why it is a 0? It is a null. Perfect. So now I'll go ahead and I'll do a write. So the color coding for here is all the blue colors are left, guys, and all the orange colors are right. Okay, that's the reason I took a different color now. So at 9, look at this hierarchy, guys. I am intending, the reason is because you'll understand. Look at the hierarchy. At 9, this is 9, this is 9. At right, again, who's my right? Anyone? Who's 9's right? It's null. Again, it's null. So what is the depth at right node of a 9? 0. Absolutely correct. It's a 0. So right now I have at 9. Let me just, oh my gosh, I can't do that. I need a hand. And just a moment. I'm just resizing here. Oh gosh, no. Little bit. No. Cool. So what are we going to do is, I am going to talk here about my left and right. So at 9, my left is 0, my right is 0. So if you look at this, what did I say? I will do this. The max of left of right plus 1. So from 9, I will say the max of left and right, in this case is 0, 0, which is 0. The max of 0 is 0. So plus 1. Because 9 itself is at 1 level. So I'm going to consider that this is my level 1, guys. Okay? And then I will return that. So the left of 3 in this case is 1. Everyone clear how I got the left of 3 as 1? Everyone following with me? Yes, no, others? Cool. I'm hoping everyone is following with me. So at 3, the right. Now I'm going to talk about at 3. So from here, I got the value as 1. My left is 1. So at 3, I'm going to say the right is, who's the right of 30, guys? Sorry, 3, 20. Perfect. It's 20. So again, a 20 will have its own left and right, correct? So at 20, my left is, who is my left, guys? At the 20? Anyone wants to take a guess? L equals to what? It's 15. Yeah, that's absolutely correct. At left, we have again a 15 here. So what I'm going to check is, at 15, what is my left again? It is no one, it's none. So I'm going to return a 0. So this is a 0. So the left of 15 is 0. The right of 15 is going to be again 0, because the reason being is it doesn't have anything. It's a child node. So it's a null. It's a 0. So at 15, the max of 0, 0, the max of this is 0 plus 1. So at 15, I'm going to say it's 1. So the left of 20 is 1. Then similarly, I'm going to talk about the right of 20. So the right is 7. Again, it will have the left and right 0, 0. So I'm going to have 1 and 1, guys. So from 20, I'm going to return. So L is 1, R is 1. So the max of both L comma R is 1 comma 1. In this case is 1. So what am I going to return, guys? 1 comma 1 plus 1. So in this case, it's going to be 2. So at 3, we say that I have 2 as my max on the right child. So we get a 1 from here. We get a 1 from here. So you return the max at Here you get a 2. So you're getting, guys, everyone, how this is going to be. So at 3, you have the left as 1 and the right as 2. You take the max of it. 2 plus 1, answer is 3. Everyone clear about the approach? It's the easiest question though, but yeah. There's so much of depth and there's so much of recursion. You might, so I think, like I said in the earlier of this class, trees is very complex, and in terms of the difficulty, it's from medium to hard. So it requires a lot of other concepts. So for today's session, I'm just talking about the basic questions. Everyone clear or any queries? So a quick summary about the question. What are we going to do is, at every step, we are going to ask, what is the depth here that I have? So for left child or left subtree, or the right child or the right subtree, we're going to ask. So repetitively, we'll be asking the same question to the each node. Whenever you get a null, you say I have a 0, and then you propagate that value back. So for this session, I'm going to write the code in Python, but you can write equivalent code in whatever language that you are comfortable with. So any queries, guys? Or do you want me to write the code? No queries? Did everyone understood the approach? Was it a lot of recursions, or is it fine? Understood, understood. What about others, guys? Was it too hard or too easy? Or maybe you want me to explain with a different example? Understood? Cool. Okay. Perfect then. So let's go ahead and I will just write. So I'll just tell you that even though the trees have a lot of recursions and all the things, but the code is quite simple. And probably the code for this is going to be not more than 3 to 5 lines. So first of all, I'm going to just check if I have a root. If I have a root, only then I can do anything, right? So I'm just going to check that if I have a root, then we're going to do certain things. If not, then I'm going to just return. If not root, like if you don't have the value again, then you're going to get a 0. So return 0. Sure, Abhishek, just give me 5 minutes. I'll done with the code and then I'll explain the summary of it. So if you don't have a root, then return 0. So that is what we were doing here, guys. If you do not have your left value, if you do not have your right value, which is a node, correct? You return a 0. So that's what I'm going to do. If not root, or this can also be meant as in Python, is that if root equals to null, or if root equals to none. The simpler way, Pythonic way of writing is if not. That's it. Else, I'm going to have my L. I'm going to construct my left the maximum of it. I'm just going to call, in this case, I'm just going to call the same method. I'm just going to call self of max step. I'm going to send the root of left. That's it. Then I'll have my right, self of max step of root of right. Then return max of L comma R plus 1. That's it. So like I said, at every position, I'll be asking the same questions. Find the depth. What is the maximum depth here? So I'm going to say L and R. Find the depth for the L child. Find the depth for the R child. Then max of L comma R plus 1. That is what I'm going to return. Is everyone clear with the code that I have written? So I'm just going to go quickly and try to submit it. And there you go. It's amazingly fast. So I think there is a problem with the language. If I take the same code and put it in Python, probably it'll be running more faster though. I don't know. Let me try it out. So why L plus R? That's amazing because I always want the maximum depth. So the L and R is always going to talk about the so far. So let me ask this question. Can anyone answer now? Like I have submitted. So yeah, as you can see, it's 97 and 55 really good numbers. So we can do it in more Pythonic way, but right now I'm not trying to do that. But yeah. Okay, so can anyone answer this question? Why am I doing this? Why are we, in this case, are we saying this? Anyone? Why a max of L comma R plus 1? Can anyone answer that question? Wants to try maybe? Should I, maybe you can just discuss with me. What is your thinking process? Why we have that? Okay, that's fine. So the reason of that, Abhishek to you and also Tamis, when you have a tree like this, let's say 220 and then 7 and 9, I don't remember the values, whatever it is. So here, while explaining, I said that this is level 1. Oh, sorry. Yeah. This is level 1, this is level 2, and this is level 3. But while implementation, I was doing the reverse psychology of it. What I was doing is, I was calling this as my levels 1, this as my level 2, and then I am calling this as my level 3. As simple as that. So if you look at here, at every step, I was just asking my each of the nodes, what does it have? So it have, here in this case, it's null value. So the left of this is 0, 0. So let me take a different color for the better understanding. So here I have the values as 0 and 0, 0 and 0. So I will say I have my 0, 0, but itself is one node, right? So that's the reason, even if my left is 0, right is 0, but itself is one depth. So that is the reason we do max of left comma right plus 1. Making sense? Are you guys following why we are doing L plus max of L comma R plus 1? So if you continue this process, we say here 1. So you send back 1, you get a 1 from here. Then at 20, you have L is 1, R is 1. So max of this is 1, 1 plus 1, you have 2. So from 20, you get 2. From 2, you get 1. So at 3, you again ask yourself, my R is 1, my right is 2. So including itself, you get the max is 2 plus 1. So the answer is 3. Clear? I hope I explained you, Abhishek. Is it clear now? Great, great. So this is how the typical tree questions are, to be honest. They require a bit of knowledge of recursion, stacks, also a bit of arrays and stuff like that. But yeah, on a very high level, this is all everything is. Any more doubts or queries on this question before I move on to other questions? Yes, no, maybe? Okay, perfect. Okay, so I have one more question. But in the interview, if the node, root node is not considered for counting the logic, should be the max of L of R. If you do, if they do not consider, yeah, that's it. I think you, what you can do is you can just return a -1 at the end. Yeah, which will essentially do the same. Yes, you're absolutely correct, Abhishek. Okay, I'll just bring on some other questions for now. So I did plan for other questions, but right now, since there's more of a, like a casual session, not bounded to something else. So what I'm going to do is I'm going to just bring on some other easy level questions where I can have all of you to collaborate with me for a solution. Okay. Okay, so the name of the question is, how many numbers are smaller than the current number? Given an array of nums, for each of the nums, find out how many numbers are in the array are smaller than it. That is, for each of the nums of I, you have to count the number of valid j's such that j is not equals to I and number of j is less than number of I. So the question is pretty much simple, guys. So if I just take this values from here to here, so and also let me increase. Perfect. So the question is here, you have a value 8, 1, 2, 2, and 3. So if I write this 1, 2, and 3 on a number system, like if you have 1, 2, 3, 4, 5, 6, 7, and 8. So the values which are less than 8 are these 7. Can I say this, guys? These are the 7 values. Yes or no? You can reply back in the chat. Yes. So if you look at the given array, what are the values which are less than 8? So the answer could be 1, 2, 2, and 3. So this is a 1, 1, 1, 1. So the total 4 values which are less than 8. Got it? Less than 1, there are no values because less than 1, it has to be either negative or 0, which we don't have. So less than 1, there's nothing. 2, we have 1. There's only one value which is less than 2. 3, there are 2 numbers, that is 1 and 2. But then again, I have 2 2s. Ideally, I have 1 and 2. Sorry, just a moment. Ideally, I have 1 and 2, but I have 2 occurrences of 2. As you can see, this entire thing is less than 3. Correct? So it can be plus 1, 3. So the answer to this question would be 4, 0, 1, and 3. Did you see here? 4, 0, 1, 1, and 3. So why do I have 1, 1 and there I have 2 ones? Because I have 2 2s. So this is 8, 1, 2, and 2 and 3. So in this case, I'm going to have 1 and 3. Is everyone clear with the input and the output? How we are getting it? Yes, no, maybe, guys. How about others? Thank you, Tazim. How about others? Others following with me on the question? So the next example there is 6548. So the values which are less than 6, what are they? I have 5, I have 4, I have 8. So that makes it 3. Less than 5, I have 4. There's only 1. So answer is 1. Less than 4, there is no 1. It's an empty. It's a 0. Less than 8. Oh, sorry. I don't have 8 here. My bad. I don't have 8. It's going to be 2. My bad. Into 2. Here in this case, I have, yeah, thank you, Chinmay. Yeah. For 8, I have 5, 4, and 6. So in this case, it's going to be 3. So the answer is 2103. Let's take a look at the answer. So yeah, 2103. Everyone clear with the input and the output? So this is also a very famous question. So as you can see, I think LeetCode is nowadays is very reliable source for me at least. You can look at the likes and it have like a huge discussion forum, so it's a good thing. So yeah, next is like the third example is 777. All the numbers are equal, no one is less than, so answer is 000. So that's it. So it have a very important technique or a data structure which we can use to solve this question. Everyone clear with the question? Anyone have any sort of doubt, any minor doubt, or maybe they want me to repeat the explanation? Oh yeah, sure, Chinmay. I will be writing the code for it. I'm just asking about the theoretical explanation for it. I will write the code, guys. Now I just explain you the question. I will explain the algorithm for it and I'll write the code for it. Okay, cool then. So before going to that, can anyone, I'll just give you probably a minute of time to go through it and maybe you guys can come up with the brute force approach, how maybe we can do it. Anyone? Shall we do that? A minute, just go ahead and think. It have many solutions, to be honest. This, at least this question does have, and it doesn't have any recursion. It's very simple and basic question. Anyone? Any techniques? No one? Maybe anyone wants to discuss? I can unmute you and maybe we can talk. Okay. Oh, I have one comment. Let me take a look. Take the first number, compare it with the other numbers, store it in a hash map. Likewise, the second, third till the end of the array. Oh, that's an amazing approach. Thank you so much, Tamis. So yeah, I will come back to the Tamis approach. So before that, let me ask you this question. This is what 8211. Okay, let me write this thing. So if you have 81223. So what are the index values? It will be 1, 2, 3, and 4, correct? It is the indices will always start with 0, correct? And these are our values. So if I sort this out, if I sort it out, what will be the values, guys? Anyone? Anyone wants to take a guess? What will the sorted array, guys? It's simple. 1, 2, 2, 3, and 8. Thank you so much, Kazim. So yeah, this is a sorted one. So if I just take a look at it, I have 0, 1, 2, 3, and 4. So this is my indices again, IDX. So can I just simply say that whatever the index it is, that many smaller numbers that I have. So for example, right now 8 is at index 4, correct? But if I do like a -1, or it's not even -1, I think it's absolutely correct. Yeah. So it's at the 4th index. That basically means that I have 4 numbers which are less than 8. Can I say this? So in the resultant array, I can simply say I have an 8 and then I have a 3, and then in case of 2, since, it is the same. So what we can do is like a -1, 1, and 1, and 0. Can I do that, guys? So when you sort it out, you already have a sorted version of it. So we don't have to calculate anything anymore. The index itself is going to dedicate it. Everyone clear about it? Any questions? But the one thing here is when you're sorting it out, you don't need to have duplicate values. If you have duplicate values, it is going to spoil things. Because in this case, the 1, 2 is getting a 2, the other 2 is getting a 1. So which one to take? We get confused. So what you can do is either here, when you have the same values, you need to replace them with the smallest value, or what you can do is you take only the values which are unique, which in this case is this. Okay? And then you give them the indices, but then you also keep a count of it, like how many 2s are there, like how many are the other numbers which are missing it out. Getting the point? So for example, the length of this array is 4, the length of this, length of the array is 5, and you have here 4, correct? So the diff is 1. So every time when you get the index plus the diff, you can also do that. There is also the second way. So this is the first way, this is the second way. Clear, guys? Yes, no, maybe. Okay, cool. So I'll just quickly write this part of the code. Okay, and then I will explain with the hash map, which one of our friend have already explained in the comments. So first, I'm going to take a new array called ARR, and then I'm going to say sorted of nums. I will have my resultant array, and I'm going to have my diff. So the diff is the length of nums minus the length of the ARR. Okay. So for now, I'll just want to show you what is my ARR and how my diff is looking like. So I'll just run the code here for you guys. So if you look at it, I have 1, 2, 2, 3, 8, and then 0. Why the length of the it is showing 0, guys? Can anyone guess it? Why a diff is 0 and why do I still have my 2? The reason for that is, guys, we have two 2's. The sorted function is only sorting the nums, but it is not removing the duplicates. So what I'm going to do is I'm going to have a set here. Set is going to remove the duplicate values and only going to keep the values. I think it's going to throw me an error. I'm not sure. No, it's fine. See, I have 1, 2, 3, 8, and the diff is 1 now. So right now, what I'm going to do is there's also an option called reversed is true. So it's going to give me from reverse, like left to right. Oh, sorry, caps. Reversed. Okay, I think this spelling is mistake. Oh my gosh, me and my spelling mistakes. Oh no, it's not though. Oh, sorry, reverse. It's not reversed. My bad. Yeah, there's an extra D. Run. Oh, sorry. Let me just show you guys why I'm doing that. So right now I have my 8, 3, 2, and 1. So that's pretty much same, correct? So what I can do is simply go ahead and find, I can just loop in from the beginning to the end, and I can just add the values to it. For example, I'm going to just say I comma C, the index comma value. I'll write index comma value in enumerate. Enumerate is a Python function which gives you the index and the value in it for the array, which in this case is nums. Okay. And then what I'm going to do is simply go ahead and, oh no, wait, I don't need this guy. What I'm going to do is I'm going to reverse, oh, sorry, force of habit, rs.append. Okay. I'm just going to append the current index value or what is the array index? So I think we can just find the index arr of copy paste dot index of, I need this value plus the diff. Everyone understanding what I'm doing? So all I'm just doing is I'm trying to find where exactly the 8 is in this array. This is my ARR. In this case, it's 3. And then I'm adding the diff to it and I'm appending to the result. That's all, guys. So this is the one way. So let me just write it as approach number 1. This is not the most optimized approach. The reason for that is the best sorting algorithm is always going to be big of n log n. It's n log n plus the n because I'm iterating one time. So the time complexity for this is n log n. Not so great. So what I can do is instead, approach number 2 is what our friend Tamis has suggested. We're going to use a hash map. How many of you are aware of hash maps? Is everyone heard the terminology hash map? Because I see some of you are like very senior and some of you are like college kids, freshers, seniors, and everyone. Hash maps. Have you heard about it? Yes, no? Quickly, guys, in the chat. Yes, great. How about others? No. Okay, how about others? Anyone? Okay. Okay, so hash map is a concept of, I'll just quickly give you an intro about a hash map. It's a concept where you store the values with respect to a key value pair. So this keys can be anything. It can be an integer value. It can be a string. It can be a float. It can be a double. So for example, I want to convert the given alphabets into a numbers or maybe each of this number like 1, 2, 3. Whenever I say 1, it means an A. Whenever I say 2, it means a B. Whenever I say a C, it means a C. Sorry, 3 means a C. So if I want to have this kind of a notations, what I can do is I can create a hash map and let's call me H map for our explanation purposes. I'll say a value 1 is going to assign it and these are the keys, guys, and these are the values. So key is 1, 2 is B, 3 is C. So this is how you write your hash map. And then how do I get the values? Simple. It's called, we're going to say, if you want an A, if you want to know what is the value stored for the key, you call it with the name and the key. So you put down the key here and you call it. This is how. So it's a very handy function. So what are we going to do in this case is when you have 8 of 1 of 2 of 2 of 3, simply we can create a hash map of it. So we can run through the array. So once you have an 8, I'm saying my current value is 8. And then I'm going to check to the rest of the array. I'm going to traverse the rest of the array and check. Okay, I'll again start from the beginning. In this case, which is 8, 1, 2, 2, and 3. My cur is 8. So my cur and I. So I is here, guys. So it should not be the same. Your I should not be your cur value. So I'm going to say no. I'm going to ignore it. Then my I is going to be here. 1, which is I'm going to check if my I is less than the cur value, which in this case is. So I'm going to create a hash map, guys, and just I'm going to store the values. The keys are going to the value of the array. Okay. So which is in this case 8. So instantiate with 0. But then I found a 1 which is greater than 8. So I'm going to just say 1. Then I move my I to here, which is a 2, which is again less than 8. So I'm increment to 2. Then again I here, which is again a 2, again a 3. Make sense? Everyone following with me? What am I doing here? Yes, no, or is it too fast? Anything, guys? So I'll just continue. If you have any doubts, please let me know. So what I'm going to continue is, but yeah, I have one more input here. Yes, but the complexity will be n square. Yes, you're absolutely correct. The complexity is going to be the n square. So for now, I'm not looking at the complexity. I'm just trying to explain you the different approaches that we can solve and also the complexity. I'm also writing the complexities at the coding level. So this is what I'm writing here. So the other ways, you can just increment this and then you're going to just say this is 4. So similarly, I'm going to run one more time. This time my curve value is going to be 1. Again, I'm going to start from the beginning. I'm going to check. So my I is 8, which is greater. So for 1, I don't have initialized to 0. It is the same. Ignore. 1, 2 is greater, 2 is greater, 3 is greater. So I have 1 as 0. Then I will have my curve value as 2. And then again, 8, 1, 2, 2, 3. Greater. So I have 1, which is 2 initialized to 0. So in this case, I got a 1, which is increased to 1. Itself, and greater. No values. Again, 3. I will have 8, 1, 2, 2, and 3. Initialize 3 here to 0, guys. Greater, less than, that means increment. Sorry. Then 2, which is less than, increment. Again, a 2, increment. Again, itself, ignore. Clear, guys? Or any queries? So if you have any queries, go ahead and please type it out. In the meantime, I'll quickly write the approach here. Index comma value, enumerate this. I'm just going to copy paste few stuff here just for the ease of understanding and quickly me writing. index equals to map of value. So here's my second approach, guys, that initially I'm initializing my entire hash map with a 0. So every value in the nums, I'm initializing that to a 0. Okay. Then I have result, which is again, all the values are initialized to 0. So the number of values that I have in num, that many times I have a zeros. Then I have my I running from 0 to the length of my nums. Initially, my count is 0. Then I'm just updating here saying that if my current number is greater than the j and this is not equals to I, the num of I is not equals to nums of j, then I'm saying count. So if you look at the question, these is the exactly same equations they have been given here. That j is not equals to I and the num of j is less than num of I. Make sense? If you look at here, it's exactly the same. I've taken the same things. Then I'm updating the count with the hash map, and then eventually I'm just iterating through the numbers and filling up the result so that I can return result. Everyone clear with the solution? Yes, no, maybe. It's a simple hash map. We could have written the same code in probably 2 to 3 lines, but just for the sake of understanding for all of you, because I see some of you are from college kids, so I don't want to make it complicated. I have written it like in 10 lines. So this is one of the leverage that we get when we use a Python as a language, guys, that you can change into whatever that you're comfortable with. You can write it at as long as you can. You can write it out as small as you can be. So let me quickly submit and show you that this is actually a right answer. Oh my God, it's been exactly a year since I submitted this. So yeah, it's very bad. The reason for that is I think Sanjay have already pointed it out. This is going to be an n square approach, guys. The reason why it is an n square is because I have a loop inside a loop is the reason it's very bad. So whereas this approach is also a very optimized version. It's an n log n. So yeah. So I just wanted to explain you the different ways of solving this is this. Any queries on the question or the implementation? Yes, no, maybe. Did everyone understand what the question is and how we solved it in two different approaches and write the code for that? Great. Should I move ahead or do you have any queries in the previous questions or the concepts? Great. I think I don't have any responses. That basically means that I'm moving ahead. So this is again a very interesting question and also been asked in some of the FAANG companies. You can also see the likes. It's 3,000 likes. It's quite a popular question. But again, it's a very easy one. I picked up an easy question. So the question is jewels and stones. You are given a string jewel representing the type of the stones that are jewels and a stones representing the stones that we have. Each character in the stone is a type of the stone you have. You want to know how many of the stones you have and also the jewels. So letters are case sensitive. So A is considered to be different from a capital. Okay, basically the thing is, guys, you have something called jewels and you have some stones. You just want to check how many jewels that you have. Okay, so for example, I have diamond, ruby, emerald, but I also have a normal white stone. But a white stone is not considered as a jewel. So that basically means I have three stones. I have a ruby, emerald, and diamond. Make sense? So here the jewels is named with the alphabets. See, you have a alphabets. So here we consider only small a and a caps a as a jewel. So how many of these I have? I have one small a. So let me just write it out here. And take a different color. So what the jewels in the first question, I have the jewel as a small a and a capital A. So these two are my jewels. And what are my stones? I think I have a small a, caps a, caps a, caps a B and an E, I think so. A small b, sorry. So I have a B, B and a B. So these are the things that I have. So now I have to go and check if this is a jewel or not. So for example, so I'm going to ask, is this a jewel? True or false? What is it, guys? Is small a jewel? Is this a jewel, guys? Yes or no? Anyone? Yes, that's absolutely right. Thank you so much, Sanjay. So the answer is yes, because this is an identical thing which is present here. So it's a yes. It's a true, guys. It's not a false. Then again, a small a, which is again this. So it's a yes. So I have a true. Then a capital A, again a yes. True. Capital A again. Yes. True. Then B. Is B a jewel? I don't find anywhere B here. So it's a no. It's a false. This B, false. This B, false. So the number of trues, guys, I have 1, 2, 3, 4. I have 4. Oh, sorry, I don't have I have a single A. My bad. I wrote like a triple A. Let me quickly erase that. So now I have 3. I have 3 truths. That means I have 3 jewels with me. Answer is 3. Everyone clear? So in the second example, if you see, you have 2 capital Z's, but the capital Z is not present in the jewel. So answer is 0. Again, this question can be solved in multiple ways. I really want to give you like a quick time, like probably a minute of time, because this is a bit similar question to what we have solved earlier. So maybe you can use one of those techniques and tell me what is the approach. Anyone wants to take a wild guess, guys? How maybe we can solve this? Okay, so let me explain you. So the first approach is simple. We can do it every time. So every time I have my jewels A, and I have my stones A, and a B, and a B, and a B, right? So I say my current value is a small a, and every time I can go through the jewels, which is in this case is this. If anywhere I found this stone as a jewel, then I say it's a true. If not, if you reach the end of the array, then I'm going to say it as a false. So in this case, I get an A, so I say a true. Then I have a cap C, which I found a true. Another cap C, I found it a true. But when the curve value is going to be a B, and I have an A and A, I have visited this, and I don't have anything, so I'm going to say it's a false. Make sense? So let me just quickly go ahead and code this out for us. So simply, I'm going to say for every S in the stones, I'm going to copy paste. And initially, I'm going to say result or count. Let me just initialize that. My count equals to 0 for every J in jewels. Copy paste again. If S is double equals to J, if they are equal, then I'm going to increase my count to a +1. And then a break. And at the end, I'm just going to return my count. So what it means, guys, if any of the stone is found in the jewels, then I'm incrementing the count and I'm breaking then and there, because then there's no need to search anymore. But if you did not find, then that means you did not find anything. So your count is going to be 0. So let me just do a quick test. See, right values. So let me go ahead and give some other values. In this case, I will give this a C. So the answer should be, guys, what is the answer for this test case where the jewel is C and I have A, B's? Anyone? I hope all of you are following with me. Anyone wants to take a guess? It's a 0 because you don't have any of the jewels in the stones. Yes, that's correct, Wasim. So let me try submitting this because I want to show you the time complexity. So if you see here, the runtime complexity is 26%, whereas the memory is 73. That means we are really doing good on the memory, but it's not so good in terms of time. The reason is, can anyone take a guess what is the time complexity for this? It's an approach 1. It's a big O of what? Can anyone take a guess? N square. That's exactly correct. Why? Why is it N square, guys? Because it's a loop inside a loop. So, can we do better than that? Answer is yes. How? I'm going to talk about it. So, I was talking about a hash map quite some time back. So, what we can do is hash map. The other advantage of a hash map is you have your set of keys and values. So, hash map searches all the keys in a big O of one-time complexity. So if you take the course, you'll understand better, but I'm just telling you a very high level overview. So what we can do is, whatever you're using the second loop to check if it is present in the jewels, this is taking the big of n complexity. So we can get that big of n time complexity to the big of one complexity. How? Using a hash map. If you create a hash map for the jewels, so if I say I have this, which is a true, and I have this, all the jewels like this, and instead of going through the entire array, I can just check in the hash map and then get the big O of n time complexity to the big O of one time complexity. So let me just quickly go ahead and code it out for us. I'm going to just copy the existing code and do this. And it's going to come from that to this. Okay. So right now I'm going to also have a hash map. That's it. I'm going to run through a loop in dwells. For every hash map of J, I'm going to just claim this as a true. That's it. Here, instead of this, I'm going to just delete the second loop and I'm going to just check in the hash map. So I can also break this out and I can say if I have a hash map, if S in H map, if my stone is present in the hash map, this basically means that it's going to check for the hash map of keys. That is these are my keys. It's a key value pair. These are my keys and these are my values. It's going to check in the keys. If it is present, then the count is +1 and then eventually going to return it. So let me just comment this out and show you how it works. Oh, sorry. Oh, my bad. Yeah. See, you get a 0. So let me just change it back to the actual version, which is A and a capsule. So you get a 3. So let me quickly submit the code and show you how it's going to change your time complexity. So earlier it was taking like 27, now it is 28, but still it's not doing so great. But your memory has dropped drastically from 73 to the 45. Because here you're not using any hash map, but you had here. In this case, you're constructing a new one. So that is the reason why there has been a drastic down. So this is good. Like I know the runtime and the memory here, you cannot completely rely on the lead code because we don't know on which and what kind of Unix or Linux system it's working on. But rather, you need to depend on your time complexity. That is what it matters. And we all know n square is bad and n is better. Correct? Does everyone agree with me? Yes, no? So I think this is how the time complexities would be. Like if we would have started from the course, I will be starting from the basics. What is a loop? How to write the loop? How to write anything in Python? Then we're going to talk about the time complexities and stuff. So this is where the instance. So this is good. This is good. This is bad. So we have n square here. We have 2 to the power n, and all of the other things are bad side things here. Then I think log n is better. It's more good. But n log n is somewhere here. So this is how the time complexities are. These are good, bad, but more bad. Got it? So which is better, guys? N is better or n log n? Sorry, n square. Who's the winner? Which is better? Anyone wants to take a random guess? And how about others? So when it comes to the interview, guys, I would say that always remember that you need to talk about the time complexities. If you are not going to talk about the time complexities, your interviewers will ask you then. So always remember, start with the brute force, go with the basics, tell them that this is how we can do it, then work upon that. You don't have to directly jump and tell the optimized version. Your interviewers are not sitting there to judge you, but they just want to understand how you're going to solve a problem. So that is what their whole intention or the aim is. Okay, guys? So that is what we have to do also. So and there's also third way of writing the same code, guys. We can also optimize this code in terms of Python because I personally love Python for many of reasons. One of the reason is that it comes very handy in interviews for me because on day-to-day basis, I work with different languages and different frameworks. But when it comes to the interview, sometimes they ask you to execute the code. And in those time, I don't want to stuck with any of the syntax or the runtime issues. So I don't want to make any syntax mistakes is the reason I go for Python. And that is how I think I started. Even though I have like a bit of professional experience with Python, but my interview coding language is always Python. So you can pick whatever the reasons that you feel. You can go ahead or whatever languages that you are comfortable with. Some people are comfortable with CPP, Java. It's up to you. And no worries at all. So the same code could have been written like this. Let me just take these two guys and nothing else. So mm, yeah, it's on the same hierarchy. Cool. Here I don't have to do this for every J N, sorry, for J N dwells, then I can just say return count or a sum of, I think so I can do that, or let me just do return count. I think so. We can always do that. We have, oh shit, my bad. Here I can say 1 for every S in stones. I'm gonna copy paste this, guys. For every S in stones, if I'm gonna have this condition here, I'm gonna call it a 1. Okay, and then I'm gonna just say sum of ARR. That's it. I don't need a count anymore. So what I'm doing is, for every S in the stones, for every stone, I'm checking if the S is present in the hash map. If it is, then I'm going to just returning the sum of it. Okay? So you can do further, like this is the one way. And also I can write in this 2 steps. How is that? In Python, thanks to Python, I can just take the entire thing, put it in place of ARR. That's it. So from 10 lines to 3 lines, from 3 lines to 2 lines. This is what the Python as a powerful language we can do. These are the kind of things that we can leverage from the language. Anything else, guys? Anyone have any queries or doubts with respect to the questions or the topics, or as an instructor, me? If it is, now I think I'm open for, I think we reached almost like the end of the session. Let me share quickly a PPT, and then one of my colleague will take over it. I think Arpita will be taking over it. Let me just share you the PPT first. So this is the overall course structure and everything. So if you have any doubts or anything, go ahead. This is the highlight, the course highlight. We are giving like more than 60 plus, and you will have the lifetime access to it. All these sessions will be recorded. You will be giving a complimentary mock interviews, and also the premium lead code questions, which are usually very expensive. And then here's about the latest batch details, which is like going on right now, and upcoming one. And this is the upcoming demo session. So if you guys request us, we are also open for tomorrow to have one more session on the DSA. Please let us know if you need that. Just put it in the comments saying a yes for tomorrow's session. then we will definitely try to schedule. We will reach out to you by email if we are going to have any session tomorrow. Okay, guys? Here are the details. So I'm just gonna put the same thing in the chat also for your convenience. Yeah, that's it from my side. Thank you so much, guys. I will be handing over to Arpita.
Yeah, thank you, Anupama. It was a really wonderful session. I hope everyone got some insights, at least from this session, and it would be useful for them. Uh, yeah, coming to the classroom sessions, we do have a training which is currently going on and started from 15th of Jan. In case you guys are interested to enroll in this particular batch, just you can contact us on the provided number, which is already shared with you guys. And apart from that, if you want to start fresh, like from a new batch, then we have a new batch which will be starting from 13th of Feb. So you can plan for that batch as well. We have already opened the registrations. With regards to this, anyone of you have any doubt, you can ask me. Just go ahead and let me know right now. All right, I guess you guys have no doubts. Then in this case, we can close today's session. Thank you, everyone. Have a great day ahead.